Assalamualaikum everyone, my name is Tahir Nusrat Khan. So today I will present lab 2, the arithmetic equation and operation. In this lab, I implemented arithmetic expression using x86 assembly language and verified the results by observing register contents in Visual Studios. Visual Studio 2019 using the debugging and dump tracks. So for my first, I have done the question 2, 4 and 6. So my question for 2 was this one. This is the arithmetic expression. And then this is there are the values. For x value, this is 26. Just a minute. For x value, this is 26. Y value, it's 30, and z value is 40. So here I move the value of x val into the EX register. Then I negate the NEG instruction to convert it into a negative value. And then I moved y value into EBX register and subtract z value from it. After that, I added EBX to EAX. Then I incremented EAX. After that, I finally move EAX to into R value. So this was my code part. So let's see the output. First, when I let's see from here, or maybe I can show you from this code. So let's run this code. The solution. Let's step over first. So you can see the line 1 is executed, and this is the output. The EAX is 0, 0, 0, 7. There's 70 and 1. So I'm sorry, there's 60 and 1. And I've put my output here. In the beginning, the x value will be this one, similar with EAX, because we moved the value of EX to x value. After that, I will step over again. Then we can see the line 2 is executed, and this is the value. Oh, sorry, this is the value of EAX right now. Okay. So after that, I will step over again and again till the call dump breaks. Okay. So I put all the value in the table from here to here by looking the register, and after that we can do like this. So it's easy, right? We can do like this. So after reaching here, we have to stop because we got our final result here. This is our final result. Like you can see, this is the execution of line 7, and we also got the R value from here because we moved the EAX value into here. So this is the final result of question 2. And so let's move to question 4 right now. So we have to exclude this. Yes. I hope it's recording. Okay. So let's clear solution. Yes. So let's move to the question 4. This is my question 4. So here you can see the code, and this is the arithmetic expression. And these are the values. Variable 1 is equal 40, and variable 2 is 10. You can see the code from here clearly. Variable 1, 40, and variable 2, 10. So now let's move to the code first. So here you can see I moved variable 1 into the AX register, then I multiplied. Okay. Then I multiplied AX by using the mul instruction. Then I moved the variable BAX, and then I moved variable 2 into bx and subtracted 3 from it. After that, I divided the value of dx by bx using the div instruction, and the quotient was shared into ax, and finally I moved into the variable 4, this one. So this is my code. Now you can see this is our output. This is our final output. Now let's do this. I have to run the code. Start debugging. So let's move debug and step over first. So this is, you can see, the first of all we have to need the ax variable, the value in line. You can see this one. The last 4 bit is our ax, and then we need the value of variable 1 because we moved the ax variable 1's value in ax. So ax and variable 1 variable will be same. So after that we multiplied 5 by this. So after this happens, we get our variable. So now I will just take over like before because it's same. We just have to match our find out our result. After this, the you can see the variable is changed. The value is changed again. Variable are changed again. So I will stop here because we already called the dumb breaks. So you can see this is our final output. Okay, and it's kind of same with this value, right? Yeah, so this is our final output. So I executed the program line by line in debug mode, similar to the question 2. I observed the values of ax, bx, and dx after each instruction and filled the table accordingly. The final result was the variable 4, this one, right? Variable 4 is 0, this one, 001c in hexadecimal. So yeah, that's it for question 4. So now I will do my question 6. So first we have to exclude this one for build and include this one for build. Okay, let's stop debugging. So let's start. Clean solution, build solution. So first of all, I cleared the DX register. You can see, first of all, I cleared the DX register to prepare the dividend. Then I looked, I loaded 803H into AX and 10H into BL. Next, I executed the div BL instruction and then divides DX by AX by BL. After the division, the quotient is stored in AX and the remainder is stored in DX. So I used dump_x to display the final values. This was my final values. This was my final value. So let me show you in the code first. So let's rebuild. So this is my output. Just let me show you in. Yeah, so finally this is my answer. You can see this one and this. Oh, okay. So this is our dump rex, see clearly, and this is our register, like ex equal 012F0380. So I ran the program using the control F5 and checked the dump rex output in the console windows. So AX is 0380 and DX is 0000. So this confirms that. So yeah, let's check this one. So yeah, so in conclusion, the lab helped me understand how the arithmetic operations are performed at the register level and how multiplication and division instruction works, how to use the debug mode and register and dump rex in Visual Studio. So all arithmetic expression was successfully implemented and verified. So thank you so much for your attention. Sorry for the inconvenience in the middle. Thank you so much.